So in this module, we're talking about what are called valence electrons and CoreNotation, which you're going to love, I promise you. All right, so first of all, definition of valence electrons. Valence electrons are all of the electrons that are in the highest principal quantum level in an atom, right? What that means is that all the electrons that have the highest n in an electron configuration. Well, when you look at, for instance, the electron configuration for gallium, 1s2, 2s2, 2p6, and so forth, the numbers in front of the letters, remember, represent n. n equals 1, 2, 3. Well, in gallium, the highest n that has electrons in it is n equals 4. So these two here, the 4s2, those are 2 electrons there, and this one here, the 4p, are all valence electrons. Notice the 3d10 in between these, it's not valence electrons because n is equal to 3. And so gallium has 3 valence electrons. Now, let's go past this. If you look at the periodic table, in the ground state, every element in the first column has 1 valence electron. Number right here. Every element in the second column has 2 valence electrons. So does helium, by the way. Skipping the transition metals, every element beneath boron, the 3A column group, has 3 valence electrons, 4 valence electrons beneath carbon, 5 beneath nitrogen, 6 beneath oxygen, 7 beneath fluorine, and neon on down, the noble gases all have 8 valence electrons. Now, in the noble gases, the transition elements, you have to look at the electron configuration, but for the most part, except for the exceptions that we talked about, chromium, molybdenum, copper, silver, gold, except for those, except for the exceptions, transition elements have 2 valence electrons. Why? Well, let's look at that. Let's pick one. Let's say manganese, okay? Let's pick manganese. Manganese's electron configuration is this. 1s2, so we're past the 2 block. 2s2, we filled this. Then 2p6. Then 3s2. And then 3p6, because we're past argon. Now we're in the 4th row, but we're past the S block, so it's 4s2, and it's not an exception. And then manganese is in 1, 2, 3, 4, the 5th column, so it's 3d5. Well, what's the highest n that's occupied? 4, right here. There's 2 electrons, 2 valence electrons. These 5 are not valence electrons. Okay. Now, let's talk about CoreNotation. CoreNotation is shorthand for writing electron configurations, and as you can imagine, as you get further down in the periodic table, these electron configurations get pretty long, pretty messy to read, and easy to make a mistake. So we have the shorthand called CoreNotation. All you do to write an electron configuration in CoreNotation is find the last, as you're reading the periodic table from left to right, top to bottom, find the last noble gas that it passed through before you got to your element, write its symbol in brackets, and then write everything after that. So for example, sodium. Let's look at sodium in the periodic table. Right there. Get rid of this guy. Sodium is in the 3rd row, right? So the previous noble gas is reading left to right, top to bottom. Before sodium was neon. So if we put neon in brackets, that takes care of all of the electrons, the first 10 electrons, right? The 1s2, 2s2, 2p6. And all we have to do is write 3s1 for sodium, just like this. Neon 3s1. Easy as that. It's good stuff.